everybody, I hope you're doing well and welcome to the platform of CodeChef. Okay, so today we're gonna be solving the problem placing Rook. The difficulty level for this problem is Cakewalk and the prerequisites required are your basic implementation. So this is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try and understand the problem statement. So placing Rook. Fluffy the squirrel is playing chess today. He has an n times n chessboard. An integer is written on each square of the chessboard. A rook is a chess piece which can attack every square in its row and column, including the square it's standing on. So if you would like to place a rook on the chessboard, it defines the score of the rook as the sum of the integers written in all the square it attacks. He wants to place exactly one rook on the chessboard. What is the maximum possible score of the rook? Okay, so what this problem statement is trying to say is that you're given an n cross n chessboard or an n cross n matrix. A rook, if it is placed on any cell, say my I comma j, then it will attack all the elements of ith row and it will attack all the elements of the jth column. Example, if my rook is placed on this particular cell, then it will attack all the elements of the column and all the elements of the row, right? And the power or basically the score of this particular attack will be nothing but the sum of elements that it is attacking, which is nothing but minus 1, minus 19 which is minus 20, and 2 plus 2 which is 4, so minus 20 plus 4 which is minus 16. So this score of this particular cell will be nothing but minus 16. We have to find that what is the maximum possible score of the rook. So in this case, if the rook attacks my this particular grid, that means the score here will be 4 plus 3 which is 7, plus 2 which is 9, plus 1 which is 10, minus 1 which is 9. And as you can see, this can be only the maximum score formed in this particular problem. No matter whichever cells it attacks, it cannot form a score more than 9. Hence, the answer for this case is the maximum possible score of 9. This is what the problem statement is asking. Now, how can we approach this particular problem statement? So, the problem statement can be simple. What we can do is, firstly, we'll initialize a row array containing all the values as 0. So, row array of length n containing all my values as 0. Similarly, we'll initialize a column array of length 0 or of all the initial values are 0, which is consisting of length n. Then what we can do is, whenever we are traversing in the matrix, so say we are traversing for I from 0 to n, and say we are traversing for j from 0 to n, what we can do is whenever we initialize the cell a of I comma j, so say we input our cell a of I comma j, we can just simply increment our row matrix or by row of a I plus equals to a of I comma j, and what we can do is we can initialize our column matrix of j plus is equal to element of a of I comma j. Okay, so what we're trying to do here is any row or basically any particular matrix of a of I comma j, I know that if it lies in the row I, then it will contribute to the sum of row of I, right? So basically, if any element or rook is placed anywhere on any ith cell, I know that all the elements in that particular row is gonna be affected. So what I'll do is I try to generate this entire row array, or basically what is the sum of this entire row, so that I know that if any of this ith cell is placed, I can easily compute my row sum in O of 1 complexity. This is what I am doing. Whenever I am getting any element, I am updating its row by that particular element and updating its column by that particular element. Or in general, we are storing the row sum and the column sum for each and every index, right? So this is what we are doing. And what we can do is finally, when we computed this value, we can traverse again in our matrix. So basically by traversing again in the matrix, for my j belonging to 0 to n, for my I belonging to 0 to n, and for my j belonging from 0 to n, what we can do is, after we computed this row value, our answer or say our cell of a of I comma j can easily be denoted by row of I plus column of j minus the value of a of I comma j, or this is my score of a of I comma j, right? So what is the score of a of I comma j? Basically what I'm saying is, in this particular matrix, say I want to find the score of this particular cell. So it is nothing but row sum or it is nothing but row sum of this particular cell, which is 4 plus 2 plus 1, which will already compute, which is nothing but 8 and 9, sorry, 6 plus 1, 7. Here will compute 4 plus 3 plus minus 1, which is nothing but 4 plus 3 is 7, 7 minus 1 is 6. So here it is 7, here it is 6, and we'll remove this extra cell because it is counted 2 times. It is nothing but 7 plus 6 minus 4, which is 13 minus 4, which is nothing but 9, and which is same as our expected answer, right? So answer is simple. Just calculate the entire row sum, just calculate the entire column sum, and subtract it with the current element. And then we can do this for each and every individual element while traversing. So inside this loop, we can do this operation and then take the maximum of all the values. And that will be the approach for solving this particular test case, right? Now, let us get a clear understanding when we see the coding section of this particular problem. So let's proceed to the coding section. Okay, now let us try and understand the code for the following problem. So here we initialize all our header files, then we define all the constants required for the problem according to the constraints. Then in my main function what I do is, I take input of n according to the input format, I traverse in my cell, or basically I traverse in my n square columns, I take the input for the particular cell which is a of I comma j, and as we discussed in the approach section, I increment that particular cell, the row matrix of that particular cell by that particular value, and we update the column position of that particular cell by that particular value, right? After that, after doing this for the square elements, we'll get any particular row of index as the entire sum of that particular row, and any particular column of index as the entire sum of that particular column, right? Then we initialize our answer as minus a big number, because every time we have to take a maximum, so we start with a minus or a negative of a very big number. Then simply traversing in the loop, as I told you in the approach section, our every element, or basically the cumulative sum of every element, can be easily defined as the row element of I plus column element of j minus the element of a of I comma j, because it is counted twice in my row as well as column element. So yeah, we subtract that particular element which is occurring extra, and then we take the maximum of it in every iteration. And then finally we have our answer at the end of these iterations. So this becomes the code for solving this particular problem. Now let us run our code on the sample test cases to see if the code is working correctly or not. So as you can see, we got the exact answer according to the output format. Now let us submit our code on the actual test cases to see whether our code is working perfectly or not. Okay, so as you can see, we got the correct answer for the following problem. And yes, this becomes the valid approach to solve this particular problem, right? Now let us discuss what mistakes people can make in this particular problem. So the time complexity of algorithm of a problem is just of n square. So any other time complexity greater than this could result in a time limit exceeded error. So here the key observation was generating my row array and column array and taking the maximum of any particular element by just simply pre-computing the row and the column array, right? So this reduced the complexity by a lot and it confined it to a big O of n square. If people tried to brute force this particular algorithm, then they might get a time limit exceeded error. This is the learning you get from watching my video. I hope you like this video. Please like, share and subscribe to our channel. Thank you.